All right. Hello everybody. I presume you can all hear me. Good afternoon. Thank you for staying around for my talk. I know it's towards the end of the day. It's my first time in Istanbul, so I'm going to go check out the city tomorrow. Just as an also note, I'm skipping my king's coronation for this. So, so today I want to talk to you about static analysis tools. So first of all, hands up, has anyone heard of static analysis tools? A few of you. Okay. How many of you have actually used them in your job? Okay, so hopefully some of you will learn something today. Okay, so a bit about myself. So I'm Jamie Lee Coleman. I am a developer advocate for Sonatype. I used to work for IBM pretty much my whole career. Worked on mainframes to start with, application servers. I worked on the OpenJ9 JVM for a while, and then did some advocacy for IBM. So who's heard of Sonatype, first of all, or used one of our products? Okay, a couple of you. Okay. Who's used Maven Central? Hands up if you've used Maven Central before. Well, we run Maven Central. So you use our stuff. If you use Java, you download Java dependencies from Maven, you're using our stuff all the time. We do this for free. We do this for the community. Sonatype was actually set up by the creator of Maven. He is my boss. Yeah, he's my boss, technically. He basically created Maven 15 years ago now and saw a problem with open source dependencies and saw a problem with Maven. So he then created Sonatype. So Sonatype is a platform, lots of different products. The one you're probably familiar with is Nexus repository. So this is what is underlying Maven Central. So behind Maven Central, Nexus repository is running it, and it runs on the cloud, on AWS. And there's lots of other tools that we provide and lots of other products. But I'm not going to go too much into those. So there's two parts to this talk. The first part, I'm going to focus on static analysis and some of the tools. The second part, I'm going to talk about analysis in general throughout the whole of the supply chain and why it's important. So part one, like I said, static analysis. What is static analysis? Well, and what should it do? Well, static analysis essentially should go through your code. It should find programming errors. It should enforce best practices, good practices, I like to say. It should find syntax violations, and it should find security vulnerabilities. This is what makes a good static analysis tool. Now, as a consequence, these tools can help us in lots of different ways. First of all, they can help us create very efficient applications. They can improve our coding skills as developers, especially if you're quite new to coding. They can also make your application code a lot easier to read and a lot maintainable further along down the line, because we all know if you write something and you come back to it in a year, it can be sometimes difficult to read, especially if the person who wrote it has left the company. It can also shorten the time from you developing something and getting it into production, which means your customers get more value, and it can make you and your team a lot more productive and superheroes, essentially, in the coding world. So those are some of the consequences. Now, this here is a vulnerability. This is a very easy mistake to make. We've probably all made it in our careers, and the difference between those two lines, one is a major vulnerability and one is not. And this is why static analysis tools are here to help us. And they sit at lots of different stages of the development life cycle. So if we look at source code analysis, which I'm going to talk about first, source code analysis could sit in your IDE, for example. So as you're typing, it could say, oh, I'm not sure you typed that method in the right way. You could definitely do it more efficient. It can sit in your source control, or it could happen at build time. So you go and create some code, you upload it to GitHub, you run a build, and then your source code analysis tool will go check your code and say, okay, this method could be done better. This is more efficient this way. So, and it can also say the way you're coding this could introduce vulnerabilities. So static analysis tools can help all over the development part of our creating our applications. Now, there's also something called bytecode analysis. Bytecode analysis is a bit different. This then looks at your compiled code. So once you've built your application, it will then go through that code. And this lives at different stages. So it can either happen just after you've built your code. It could happen when you put it into a repository. It could happen when you put it into a release. And you can also look at the bytecode when your applications are in operation. So bytecode analysis, what does it do? Well, it essentially generates a map of your application, and it looks for two things, the entry and exit points, which are called sources and sinks. And what it does, it maps out essentially where the data goes through your system, and if that data is not being handled correctly, it knows there's a problem there. And then it can find, okay, this is a way a bad actor or a hacker can attack your system. So it's quite good. And it also is a lot more accurate than scanning the source code. So there's lots of different ways you can do this, but essentially it makes sure that the data that's coming in your system is cleansed, and if not, that's a problem. Now, the advantages of bytecode analysis over source code analysis are things like I mentioned, higher accuracy, custom rules, because things you need to remember is there's lots of false and positive negatives. It may think that you're doing something wrong, and realistically, that's the way it should be done. So it's a lot more accurate in that way. You can define sanitizers. So, for example, if it's hitting this error and it's saying, okay, you've got a problem with your code here, and you said, okay, no, that's not an error. It's meant to be like that. You can then set up rules to say, ignore this in future. So it's very customizable. But you can also do that with source code analyzers as well. You just have a lot more, you have a lot more control when you're using bytecode analyzers. And it can basically trace your data as it goes through the system to make sure there's no leaks anywhere. Now, the disadvantages of bytecode analysis over source code analysis is it's very, very slow. It's very resource heavy. So if I go back to here, there is a reason this doesn't run here, because it ends up setting our laptops on fire, pretty much. So these kind of things then run, on mainframes, on the cloud, etc., because they require a lot more processing power. So, things that you would consider with static analysis tools, because these tools are great, and there's lots of free ones out there, so there's no reason why you shouldn't be using them, but there are problems. For example, a tool is only as good as the people who create it. It's only as good as the data that backs it up. So there's lots of different tools out there, but if the team creating it and the data that backs it up is not sufficient, then it's not going to be a very good tool. If you're using a tool that isn't backed up by data to say, this is the right way to code, this is the wrong way to code, this will introduce a vulnerability, this won't, then it's not a very good tool, is it really? And who decides what is best practice, right? I mean, what is a good practice for someone might be not the right practice for them. I mean, Java developers, we're quite opinionated on how we code things. We like to think we're the most efficient, but then you might find someone else who thinks that it's better to program in this certain way. So defining what the best practices are can be difficult. Now, some of these tools do allow you to define what you think in your team is best practice. So you could have one team a set of rules for them and another team a set of rules for them. So these tools are generally quite customizable. You've got to remember about false positives and false negatives. So these are kind of things where, for example, you might, it's flagging up that this is a vulnerability when it isn't, or it's flagging up that a piece of code here might be a vulnerability, but you're not using that piece of code. So you've got to keep in mind that these tools, as good as they are, they're not always perfectly accurate. They do make mistakes, and you have to be aware of that. You have to catch them, and a really good tool is a tool that allows you to basically create rules to say this is good and this is bad. And like I mentioned, there's customization with customization per team for some of these tools. So a few other static analysis terms. First of all, control and data flow analysis. So control flow is essentially watching the flow of your data as it goes through the system, and essentially you can represent it in a graph. And what this does, it kind of it knows what instructions are going in, and it kind of figures out the edges of your system. You also have data flow analysis, and this is very similar. It's basically designed to gather data about different parts of your system over time, and it's often used to optimize your code to make your applications run faster. So there's also the term dynamic analysis. So what's dynamic analysis? Well, testing, we all know what testing is. I presume you're all doing some testing, so that's part of dynamic analysis. Monitoring, so when you've got your stuff into deployment, monitoring it to making sure it's efficient, etc. And there's also something called program slicing. And program slicing is essentially where you have your application, you try and reduce it down to basically the behavior you want. So you remove all the stuff that isn't anything to do with what you're trying to do, and then to analyze it like that. And that's called program slicing. So what tools are available and what tools what these tools should do? So in my opinion, a good static analysis tool should enforce coding standards. As you can see, I've said coding standards, not best practices, because that's up for interpretation. It should find insecure coding patterns. So if you're coding in a way that might be insecure, it should be able to pick that up and tell you you're doing that wrong. It should measure your test coverage. So it should be able to look at your tests to make sure your tests are essentially doing what they should be and testing everything they should. Like I mentioned, it should do control flow analysis and data flow analysis. And if you've got a really powerful tool, they can even look at your documentation and look at your code and say, your documentation is missing this because you've coded this and you haven't talked about this in your documentation. Go and write some documentation. So as you can see, these tools really are here to kind of make us better programmers. We're all going to be on teams where you've got that one epic programmer. He seems to be much better than the rest of us. Well, these tools help you get all onto the same level. It will help the newer people in the organization get up to the same level as the people that have been there for 30 years or 25 years coding Java by enforcing the same standards throughout the team. And like I said, they can happen at different stages. You can happen in your IDE. There's quite a few tools out there in your IDE that as you type, it will tell you this is the wrong way to do it. You can do it at build time, or you can do it when you're scanning your source code, so in a GitHub repository or something like that. So there are lots of different tools available. I'm just showing you some of the free ones. SonarQube, this is basically quite a low-level one. This will find vulnerabilities, bugs in your code, things like that. And it can work at the level of you typing, so kind of at the IDE level. You've got SemGrep, which is a static analysis tool, and it basically enforces coding standards. And a new tool, which I've been introduced to over the last month at a conference, was Open Rewrite. So Open Rewrite is kind of when you've coded your application, you run one of these tools, and it'll flag up, oh no, I've got 10,000 things I can improve here. Well, as a developer, I don't want to sit there and go and fix 10,000 errors in my code. But Open Rewrite can do all of that en masse at scale. I've only played with it a few times. It's not really a new tool. It's been around about a year, but a company has now been formed around this to give support to it. So it's now getting a lot of love from the community, and it is quite amazing. Now, not all of us would want to take a massive enterprise application, use Open Rewrite, and do 100 commits to fix the code. We might want to do it a bit at a time to make sure we're not breaking our application, but these are just some of the options you have for writing this stuff. So I'm going to show you a very quick demo, just as an example of one of these tools. This is Sonatype Lift, so this is something Sonatype have created. It's a free tool at the moment. We basically created it to figure out how to write these tools in the future. So essentially, hopefully, some of the capabilities of Lift will go into Sonatype's enterprise products. But Sonatype Lift doesn't live on your IDE. It lives at your source control and your build level. So when you upload something to GitHub, you can use the Sonatype Lift integration, which will then scan your code, and then basically suggest things you can make better, things you can adjust to make it more efficient, and it will pick up vulnerabilities and security problems. But like I said, this sits in the source code and the build level. So let me try and give you a very quick demo of that. Now, the reason we decided to put it at the source code and build level is because it's a cloud kind of tool, and on the cloud, it's got a lot more power, whereas if it's sitting in your IDE, obviously your IDE isn't going to be as powerful enough as something that's running on AWS that has a lot more data, like straight away, etc. So that's why we decided to live there. But realistically, you should be doing static analysis at every part of your build. Now, let me see if the demo gods are happy today. Okay, cool. So this is test containers. I don't know if you've heard of test containers. Test containers is a framework for basically running unit tests and integration tests in a container. I'm not going to talk too much about it. Oh, you're not even looking at my screen. Okay. So test containers, if you haven't heard about it before, it's a pretty amazing framework, and it basically will allow you to kind of mimic what you have in your development environment, in your production environment. So it means getting from A to B is a lot quicker. Now, as I can see here, it's given me some things to fix. For example, it's looked at the test containers library. Bear in mind, this is an open source library. I didn't write this, so don't blame me for any of the problems in here. But it'll give you things that you can fix. So for example, using a collection function with itself as an argument, you shouldn't be doing that. For example, the local date.now is not allowed because this just uses the system default time zone, and you should be declaring a time zone. So simple things like this essentially allow you to make sure your code is better, it performs better, and it doesn't have vulnerabilities in it. Now, Lift does have lots of other different functionalities. We can look at our dependencies, and we can see vulnerabilities, etc. But I'll talk a little bit more about that in the second part of this talk. But like I mentioned, this is a fully free tool. Feel free to use it. It can export SBOMs, and if you don't know what an SBOM is, I'll talk a little bit about that in the second half. But like I was mentioning, there's lots of these free tools around, and there's no excuse as to why us as developers aren't using them to make our code even better. Because we all want to be that guy in our office that seems to be able to code better than everyone else. All right, so now part two. Now, static analysis, hopefully now you're kind of aware what static analysis is. You know some of the free tools that are around. You know kind of what parts of your development lifecycle it sits in. Now I want to talk about the rest of the supply chain. I'm going to scare you all a little bit with some crazy facts here. But okay, so we've got our bytecode analysis. We've got our source code analysis. Now we've got software composition analysis, or SCA. So hands up, anyone heard of software composition analysis before? Nobody. All right, okay. That's worrying. Okay, well, software composition analysis. I try to use the cake as an analogy here. So from this cake, I can see that there's some sponge, and there's some icing, and some food coloring, right? Take your application as an example. In your application, you have your Maven POM file or whatever, and you're using open source dependencies. Now, as a first glance, I can look at my Maven POM file and say, I'm using Spring Boot, I'm using this, and I'm using that. But that is just what you can see. Do you know how many dependencies Spring Boot pulls in underneath? Do you know how many dependencies those dependencies pull in underneath? That's quite a lot of dependencies. So this is quite important, and people forget about this. So we all use open source code. I presume we all do. Open source code is amazing. It's really started to become popular over the last 20 years, but it gives you the freedom to study, copy, modify, redistribute, all these lovely things. But did you actually think how much of your applications is borrowed code from someone else? Over 90% of all the code in our applications is code from somebody else. That's 90%. Do you know how good that code is? Do you know how many vulnerabilities are in that code? Probably not, especially if you don't know what SCA is. So let's put this into perspective. These are some of the problems we have with our software supply chain today. So an average Java project on GitHub has around 150 dependencies. Those dependencies have 10 releases a year. That's 1,500 updates we should be looking at every year. And I guarantee most of us, including myself, does not do that. You've probably seen this architecture picture before, and this pretty much sums it up. We're all using this open source code. Some of it is really fundamental to what we're building. But this guy in Nebraska, who's been thankfully maintaining this open source library since 2003, what do we know about him? How do we know he's a good guy? How do we know that this code is secure? How do we know it's efficient? So this is what I kind of want you all to think about, is that we are borrowing most of the code that is running in our applications, but we're not thinking about the consequences of doing that. And don't get me wrong, like, open source code is amazing. Imagine if we had to code 90% more for every application we made. That's a lot of time spent. So sharing is, code is amazing. But the bad guys are starting to figure this out. The bad guys are starting to realize that, okay, the days of breaking through firewalls and that, etc., they're coming to an end. So they're getting very clever about how they hack into our systems now. So like I mentioned, this is Spring Boot. So it's one dependency in my Maven POM, right? But then that pulls in these dependencies. And then that pulls in these dependencies, and so on. So how much do you really know about your applications if 90% of them, the code has come from someone else? So static software composition analysis tools, they basically should go deeper. So back to the cake analogy, I can see it's got icing, I can see it's got sponge, but what makes up the sponge? What makes up the icing? And that's what these tools, good tools, should do. They should look at your dependencies, they should look at the dependencies that those dependencies are using, and they should know things, for example, do those dependencies have vulnerabilities in them? What is the licensing of those dependencies? They can give you project scoring. So a project score comes from lots of different data. It can come from the open source projects. How well are they maintaining it? How often do they release? If there's a vulnerability, do they release the next day a fix? Do they do it in a week? Do they do it in a year? So these kind of tools, they look at all these different things. And like I mentioned, the bad guys, they're getting very, very clever at the way they get into our systems. So now some very scary facts about cybersecurity and why we should care about it. So in 2016, cybersecurity took over the drug trade in terms of how much money it makes. That's $450 billion a year. That's equivalent to $14,000 a second, and that's equivalent to 50 US Nimbus nuclear aircraft carriers. That was in 2016. What about 2022? I don't have data on 2023 yet. But do you think it's increased? Of course it's increased. What is it now? Well, it's now $6 trillion a year cybercrime makes. That is a lot of money. That's equivalent to 620 of the US's biggest nuclear aircraft carriers. Bear in mind, they only have, I think, 8 or 10 of these, but cybercrime, they can pay for 620 of these a year. And guess where they're making that money, everybody? From our insecure applications. And if cybercrime was a country, it would be the 3rd largest country in the world by GDP. So today's Pablo Escobar, he wouldn't be selling drugs anymore. He'd be in cybercrime because there's a lot more money in it, and these people very rarely get caught. A lot of them are in obscure locations around the world. They're making millions and millions of dollars, and they probably won't ever get caught. Now, things have changed, and say in 2006, when a vulnerability was announced to the world, this open source dependency has a vulnerability in it, you had on average 45 days to fix that problem before you got hacked. Now, who remembers Log4j? Hands up. Some of you must have, yeah, thank you. So Log4j, that was down to about 2 days. From the day the Log4j vulnerability was announced, within 2 days, hackers were taking down companies all over the world. So this was definitely the worst, I should say, Java vulnerability in the world, let alone probably of any language. A lot of companies got into a lot of trouble, a lot of shit because of this, essentially. And it's not just enterprise applications. Everything has open source code in it now. Medical devices, insulin pumps, aircraft, trains. I was in Germany a year ago where their train system got taken down. And Germany's a very efficient country, so you can imagine their train system gets taken down for an hour. Oh, the Germans don't know what to do. Well, guess what? It got took down for a whole day. Why? Because there was a vulnerability in their open source code that they didn't fix. They thought they had time, and the hackers took down their train network for 2 days or a day or something like that. But imagine if you're in an aircraft and they hack the aircraft. Imagine if you're driving in your car really fast down the road and someone manages to hack it and take control of it. And cars do have that ability to drive themselves nowadays. So this is just a reiteration of why code analysis and security is very, very important. Just took the time. Okay. But things are changing around the world. We're probably not going to be happy about it, but governments around the world are introducing legislation to essentially make us, as developers, and our corporations and our companies responsible. So if you, for example, introduce something into, I don't know, some open source code into your application, and you are supplying that to the government or something like that, you can go to prison for that. And this is coming. Now, my boss made this great quote, and he kind of said, if no other manufacturing industry is permitted to ship vulnerable or defect parts, then why, essentially, are software engineers allowed to? Why are we allowed to do that? You wouldn't have a plane be given to a customer with a defective engine or a defective wing. But so why are we as software engineers allowed to do that? Well, the governments of the world have all figured this out, and now they're going to make us responsible. So this was announced in the US. My boss has actually been going to the White House to work with the White House to kind of create this. But this came up in the US, where basically, first of all, if you want to sell your software to the government, you have to produce a bill of materials, which I'll talk a little bit about in a moment. You also will now be held responsible for anything that happens. The EU has also just come out with their Cyber Resiliency Act, which says lots of things like that, so you're going to be responsible. Also says things like, if you know there's a vulnerability in your code, then you have to tell them there's a vulnerability, you have to tell your customers, and you have to give them a solution or a time frame of how long it's going to take to fix that code. Now, this is an EU law that's coming into effect in the next year or so. The UK is lagging behind because we're always lagging behind, but similar thing in the UK. They were basically trying to make us as software developers and our corporations responsible for the products we ship, because we shouldn't be shipping vulnerable products. We shouldn't be shipping products that hackers can get into and cause mayhem, because hackers, they're not just the same as they once were. Some of them are doing it for their country, for their state, etc. And these are the dangerous ones, because they really are there to inflict damage on your country, essentially. That their job is to get in and cause as much havoc as possible. They're also being very sly. So they're doing things like they'll pretend to be an open source maintainer, and they'll be there for 6 months. You know, they've added some really good functionality into this dependency, into this open source library, but they're really only there to hack you later on. So now the community's like, yeah, they're really good, they've done a good job. They sneak a vulnerability in, and they can take down so many corporations just by doing that. So there's lots of different ways that they are essentially trying to attack us these days. So SBOMs. Anyone heard of an SBOM? Software Bill of Material. Okay, a couple of you. So this is something that is being required by the US government and by the EU. Like I mentioned, the UK is still trying to catch up. But essentially, it means you have to produce a bill of materials of everything that is in your application. So all the dependencies, all the open source code you're using, you have to tell the government when you ship that software to them what exactly is in there. But the problem is, well, a list of stuff that's in my application isn't really going to fix anything, is it? It's just one small part of the solution. So if you haven't generated an SBOM, There's no harm in doing it at the moment. Just generate one, see what's in your applications. There's lots of free tools to do it. Maven has the ability to do it. Kubernetes has the ability to do it. Even GitHub now has an option where you can just select generate SBOM, and it'll generate an SBOM for you. So there's lots of different ways to do it, but just having a list of materials isn't really the solution. You need to do something with that list. And the hackers are getting even more clever because now they're hacking into our SBOMs. So they can actually hack into your SBOM and essentially change the dependencies to ones that don't have, change the dependency versions to ones that don't have vulnerabilities. So your customer, you've shipped this application to them, they've gone through your SBOM, they've gone, okay, yeah, I've looked at all those and there's no critical vulnerabilities there, okay. But a hacker has actually got into that SBOM and changed it. And then when this is deployed to a customer, they then go and hack them and ransomware them or whatever they want to do. You can sign SBOMs, so there are security around them. So if you are using an SBOM, a software bill of materials, as part of your overall software solution, then you should also sign it to make sure hackers can't attack it. Now, about 2 years ago, most of these organizations didn't exist. But again, I think after the Log4j incident, we started to get a bit worried about hackers, and the governments of the world started to create foundations, and these are really to enforce standards, so to enforce best practices when creating applications, etc. Now, one of the simplest ways to improve your security posture is code reviews. So these are the things that, the OSSF Foundation, they have a tool which goes and scans projects, and essentially they have identified what is the highest criteria for an unsecure project. And code reviews is one of the main ones. Now for me, I've been doing code reviews since the start of my career, so it's nothing new. But that really makes a massive difference to how secure your project is, because having a second set of eyes to look at your code really does make a lot of difference and stops you making, like you saw at the start, that tiny mistake that could be a vulnerability from not a vulnerability. Now, there's also lots of different ways you can improve your security. These are the 4 main ones that the OSSF Foundation have identified as key indicators to having a secure project. And to finish off, I'm going to give you a very quick look at Bomb Doctor. Now, this is a completely free tool to use. You can just point it at GitHub repo, and it'll do the scanning for you. But essentially, okay, so I'm just going to view a sample project here. So Bomb Doctor is really cool because it kind of gives you gamification of your application. So imagine I've produced an SBOM, I've given it to Bomb Doctor, and this is what I'm using in regards to, I'm wondering if I can get a better project. They changed this recently, so it samples around the projects. I don't know why. I'll try to get the Spring Boot one to come up. If not, I'll just leave it on whatever's here. Ah, Spring Boot, lovely. Okay, cool. That was lucky. Okay, so this is Spring Boot, for example. And like I mentioned, you're just downloading one dependency into your POM. That's actually what you're downloading. And you didn't code any of that. Well, you might have. You might be a contributor on these projects. But what Bomb Doctor does is it helps you visualize what a good project looks like in terms of security, good coding practices, etc., and what a bad project looks like. So what it does, it gives you a score here. That score is out of 500, as you can see, and it will also list things like major vulnerabilities. So if I go to my SBOM report here, I can scroll down. I can see that Spring Web, that has a critical vulnerability in that a hacker can get to. Spring Web MVC, it's got a severe one. This one, Snake YAML, that is very, very vulnerable dependency. But like I mentioned, you as a developer, you're just pulling in Spring Boot. You're not actually pulling in all this, but you are underneath the covers. Now, what you can do here is you can play around with it. So it won't suggest changes if it's going to break your code. So it knows that an upgrade or a downgrade might break your code, and it'll tell you, okay, if you upgrade to this version, you might have some breaking changes, etc. But what it can do is, so I can click on here. This is running at version 2.7.4, and here it's basically saying there's a better version available, which 3.0.6. All right, let me click on the upgrade there. I don't know why it's taking me to another page. Oh, view version. Okay, sorry. So, all right, let me take this one, for example. So there's a better version available here. I can do a quick upgrade to the best version. And what that will do is it'll refresh my whole application graph. Okay. Try again. Basically, what it'll do is it'll refresh my whole application graph, and the score, as we upgrade these things, should increase. Because, okay, ignore this. So what it should do is the score should increase. And then you have the ability to make a pull request. So this is actually not making pull requests to your system. This is essentially just upgrading different parts so you can get a better idea of the best versions of each dependency to have in your system. I'll try it one more time, and if it breaks, I give up. There we go. So the score for that one has increased slightly. I can go here. So there's an update to best version, or you can do a quick update. Now, like I mentioned, sometimes it may turn around to you and say, okay, this has got breaking changes, so don't do it. And this can also, you can get provided with a report. So what you can do is you can scan certain projects, you can go back to maybe your team lead, etc., and say, look, we're using this dependency, it's running at this version, it has these vulnerabilities in it, maybe we should upgrade it or downgrade it to one that's more secure. And it doesn't also take security into account. As you can see, it takes licensing, so make sure the dependencies you're using have the right licenses, and popularity. Now, what does popularity actually mean? Okay, so popularity is essentially things like I mentioned, how many people contribute to this open source project? How many releases do they have a year? If a bug comes out or a vulnerability, how long does it take them to fix it? How many people are talking about this project on the web? How many people are using it? And to be honest, I mean, if there's a heavy usage of an open source dependency, it's likely to be better maintained than one that isn't. So that is my very, very quick demo of Bomb Doctor. Again, it's completely free, so do check it out. If not, just have a quick scan of your applications and just see what score you get. Have a play around with the updates and see if you can increase that score. Because if you can, that might be a really quick win for you to go back to your team and basically say, look, if we update this, 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 and this, which is like 4 lines in my POM, we would be so much more secure. We'd have 10 less critical vulnerabilities, all kinds of things like that. So to kind of summarize, to end my talk, because I know we're getting to the end of the day, just want to reiterate, small mistakes can have very big consequences, and static analysis is there to make sure, because we're all just human, static analysis is there to make sure we don't make stupid mistakes in our code, because it happens all the time. I do it all the time, and that's what it's here for. It can help us in many different ways. So, like I mentioned, it can find programming errors, it can enforce coding standards, it can find syntax violations, it can find security vulnerabilities. But as a consequence, it can make our applications more efficient. We all want more efficient applications. It can improve our development skills because it's basically trying to push us to the kind of expert level that the experts in our team are. It can make your application code easier to read when you come back to it at a later date. It can shorten the time to get something in development into production. And it can make us all essentially heroes. So all software analysis is important. It can live at pretty much every stage of your development lifecycle, your supply chain. When you're downloading from Maven Central, some of this stuff is being done for you, which you probably don't realize, but not everything. So it's best that we do these checks ourselves. Now, this is just a graph. So because we run Maven Central, we have a lot of data about what people download. This is the Log4j vulnerable version that came out over a year ago. At the moment, 157 million times that's been downloaded, and a year later, 29% of the downloads of Log4j are still that vulnerable version. Still, a year later, this was the biggest vulnerability probably in coding history, and 29% of people are still downloading that vulnerable version. So you may be lucky, you may be still using that vulnerable version, but when a hacker figures out your company's using that vulnerable version, your luck may run out. And nowadays, if you're in a small to medium-sized company, it's pretty much the end of your company. They can ransom you and take you down completely. And then you'll end up being out of a job. So that's what I wanted to reiterate, that security is very important. We're borrowing code from everyone around the world, which is amazing, but we've got to be sensible about how we use free code that someone in Nebraska has written. So these are a few useful links to some of the stuff I've talked about today. Maven Central is also looking for a new logo. We haven't changed the logo since it was deployed. So if anyone's got any ideas for a new logo, please tweet me or send me a message or Sonatype, and we'll take that into consideration, because I'm not a designer and I definitely can't do it. So yeah, Maven Central is going for a revamp and we need a new logo. Here's some useful links to some of the tools I talked about today. There's a link to the new Maven Central there. The FooJ series talks about the importance of security in the supply chain. And Sonatype also released a monthly blog where we basically talk about what the bad people have been doing the last month. So yeah, check all that out. If you do get a chance, please check out Bomb Doctor again. It's all free, it's fun to use, gamification. And just wanted to reiterate that we all can be superheroes, we just need the right tools to do it. And thank you, and enjoy the rest of the conference.